Everyone, welcome back. So in this video, I'm going to discuss about the 802.11 frame format. You all know that 802.11 is the standard defined for wireless local area networks. Okay, so in this, let us see what are the different fields that this particular frame has. The 802.11 standard actually defines three types of frames. The first type is a data frame, the second one is the control frame, and the third variant is the management frame. Each one of these has a header with a variety of fields used within the MAC sublayer. Now just let us look at the frame format itself. So you can see that the frame starts with a frame control field, followed by a duration or ID field, and then we have 4 address slots here. Address 1, address 2, address 3, address 4. In between we have a sequence control slot here, and then a data field, and finally the FCS field. Okay, so let us start here. The first comes the frame control field, which is made up of 11 subfields. The first of these is the protocol version, which is set to 00. If you observe, whenever you're answering such question, please ensure that when you draw the frame format, you have to mention the size of each field length. What is the length of each field? You have to mention, whether it might be in bits or bytes, you have to mention it on top. The frame control field is of 2 bytes in length. 2 bytes means 2 into 8 bits, which gives us 16 bits. So in this frame control field, we have many subfields. You see the version is 2 bits, type is 2 bits, subtype is 4 bits. If you add all these together, you should get the final length of 16 bits. Check it out. 2 plus 2, 4, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So your frame control field, which is of 2 bytes, contains all these subfields. Of all these subfields, the first one is version, which is of 2 bits in length. Now, please remember that for all the current usage of 802.11, the version is set to 00. So your 2 bits are always 00. After the version, then we have 2 different fields called as type field and subtype field. Type field is 2 bits in length and subtype is 4 bits in length. Now, if you remember, I just told you that we have 3 different types of frames. The first frame is called as data frame, or the first type is data frame. The second type is control frame, and the third type is management frame. I'll show you the different combinations of type and subtype fields where a receiver will be able to identify what type of frame is this. Okay, now this is what you can see. If the type is given as 00, it is a management frame. And which type of management frame is actually defined by this particular 4 zeros, the next 4 bits. If it is 00 and if it is 0000, then we say it is as an association request. Please remember that the management frames are used to establish and maintain communications within one BSS. BSS actually stands for basic service set, which is controlled by one access point. Okay, so this is the role played by the management frames. You can see these are all the different management frames, which one of the most important one is the beacon frame, association, reassociation, request response, authentication, de-authentication, disassociation. So all these are used to maintain the connections, the communication happening between a particular device and the access point. The second variant, where the type value is 01, is a control frame. These control frames are actually used for maintaining the access control, or for implementing the access control, controlling the access to the shared medium, and also for frame acknowledgement. You can see here there are the short frames which we discussed during the MAC sublayer implementation: the request to send and clear to send, the ACK your acknowledgement frame. So these are all the different control frames, the type and subtype for each one of the control frames. And the third, the last one, is your data frame, for which the 2 members are 10, and these are the 4 bits of your subtype. So the type field is 2 bits in length, and it distinguishes between management, control, and data frames. The subtype field identifies the specific frame subtype. So which type of management frame it is, or which type of control frame it is, or which type of data is being sent. All those things are given with the combination of your type field and subtype field. So after these things, we have multiple flags here. That means I say flag because all of these fields are only 1 bit in length. That means they are either true or false. So it can be either 0 or 1, right? So I discussed about the protocol version where these are all zeros. There are 2 bits, it is 0. And we have next the type, which is of 2 bits in length, and then the subtype, which is of 4 bits in length. And after these two fields, these are the ones which are following in your frame control field. So let us discuss each one of them in detail. First one is 2DS. Actually, DS stands for distribution system. We discussed this during our discussion of 802.11 structure or architecture. So if it is set to 1, it indicates that the destination frame is for the distribution system. It is going towards the distribution system. The next field is from DS. Automatically, these both should be self-explanatory. If I'm putting a 1 bit here, it is saying that the frame is going towards the distribution system. And if I'm putting a 1 here from DS, if it is a 1 bit field, 1 bit long field, which one set indicates the frame is coming from the distribution system. Okay, so these two identify which way the frame is traveling. Either it is going to the distribution system or it is coming from the distribution system. The next one is more fragments. This will indicate the receiver that if you are setting it to 1, this will indicate to the receiver that there are more fragments which are going to follow for this particular frame. Okay, so for this frame, how many? There might be multiple fragments, and there are more fragments which are coming for this particular frame. For that, we show it in this particular field, more fragments. Then you have something called as a retry field. So if this field is set to 1, which will indicate to the receiver that this particular frame is a retransmitted frame, but not a fresh one. So if the current frame is a retransmission of an earlier frame, then you set this bit to 1, which will tell the receiver that this is a retransmission, not a new one. Followed by the retry bit, we have something called as the power management bit. So power management bit will tell or will indicate the mode of a station after transmitting a frame. If you set this bit to 1, it is telling to the access point that the station is going into a power saving mode. If it is set to 0, the station stays active and it is not going into the sleep mode. So either 1 or 0. 1 means it is going into power saving mode. If it is 0, it tells you that it is active. It is not going into power saving mode. Okay. After that, we have another field called as more data. So once again, more data will indicate the receiver that there are some more data or there are some more frames which have been buffered and which will be sent after this frame. Please do not get confused between more fragments and more data. More fragments will indicate the receiver that there are other fragments that follow this for the particular frame. More data means there are other frames which are to be sent to this receiver. This particular field is useful when to indicate the receiver that a sender has more data to send than the current frame. This can be used by an access point to indicate to a station in power saving mode that more packets are buffered, or it can be used by a station to indicate to an access point after being polled that more polling is necessary as the station has more data ready to transmit. So in simple terms, if I'm setting this more data bit to 1, I'm indicating that there is more data which is to be transmitted. So you can, if I'm going to tell to the access point that please poll me back again so that I want to send more data, or even the access point conveying to the station saying that there is more data destined to you, so please be active. So this is the field that we use for this, more data, and it is followed by the protected bit. This protected bit is also called as a WEP bit, which stands for wired equivalent privacy. Once again, if it is set, then you are indicating to the receiver that WEP is used. The standard security mechanism of 802.11 is applied for this particular frame. If it is 0, then no protection is applied for this frame. So if it is set to 1, you are conveying that security has been applied and WEP has been implemented. If it is a 0, you are conveying that there is no protection implemented for this particular frame. The last field is called as the order field. Once again, it is 1 bit in length. So if I am setting this order bit as 1, which means that you are telling the receiver that only the frames should be processed, or the frame should only be processed in the exact order. inordering of the frames is not permitted. So the bit is set to 1, the received frames must be processed in the strict order only. So these are all the things which comes under your frame control field. Your protocol version, which is 00, your then the type of the frame and the corresponding subtype of the frame, to DS from DS, both indicating which direction the frame is traveling, then followed by more fragments, which conveys to the receiver that there are more fragments that belong to this particular frame. Then the retry bit, which will tell the receiver that this particular frame is a retransmission but not a original one. Then followed by the power management bit, which will convey the current mode, whether it is the current mode of the station, if it is going into a power saving mode or if it is going to remain active. More data field, which will tell the receiver that there is more frame or there are more frames that are buffered or that are to be sent. And then comes the protected bit. This particular bit, when if it is set, then it will convey that the WEP has been implemented, or protection or encryption has been implemented for this particular frame. And finally, the order bit will tell that if whatever frames are received, they have to be processed in the exact order only. So all these fields make up your frame control field. So if you remember correctly, I'm just going back. If you see, this comes under your frame control field, which is of 2 bytes in length. Following the frame control, we have the duration field. So this duration field, what it does is, it will actually convey the information regarding how long or how much duration that the transmission is going to take place for. So it tells how long the frame and its acknowledgement will occupy the channel, measured in microseconds. Okay, so it is present in all types of frames, including control frames, and is what stations use to manage the network allocation vector mechanism. During our discussion about the MAC sublayer implementation of 802.11, we discussed that the DCF function implements network allocation vector, from which each station maintains this to implement the virtual carrier sensing technique. So based on what you take the network allocation vector, or on what you update this NAV, is the information from the duration field. So the duration field is going to tell you how much the current frame and its corresponding acknowledgement are going to take place on the channel, so that other stations, by looking at this particular duration field, can update their network allocation vectors and perform virtual carrier sensing. Sometimes an ID is also carried out, which is used for the management frames as an association ID. Okay, so next comes the fact that there are 4 address fields that we discussed during the frame format. You might wonder why we need 4 address fields, right? So here, the positions of these address fields are actually dependent on the combination of the 2DS and from DS bits of your frame control field. So based on these 2 bit positions in the frame control field, they define which address is placed in each one of these fields. There are 4 address fields. So to give you a better idea, let me treat each one of these things as cases. So this is case 1, this is case 2, this is case 3, this is case 4. In case of case 1, when 2DS is 0 and from DS is 0, that means a station is directly sending to another station. Then the address 1 field will have the destination address, the address 2 field will have the source address, the address 3 field will have the BSS ID, which is your basic service set identifier, and the address 4 field will not be applicable. It is 0. It is 0 bytes. This is case 1. If it is sending directly, you can see that B is the destination, A is the source, and your 3rd field will contain the BSS identifier, and there is no 4th field here. What about case 2? If 2DS bit is 0 and from DS bit is 1, then you can see here, the first address field will contain the destination address, which is B in this case. The second address field will now contain the sending access points address. You can see that this is one BSS which A belongs to, and this is another BSS. These 2 BSS are now combined by or connected by the distribution system. This is the access point. So your address 2 field will contain the address of the sending access point, and your 3rd address field will contain the address of the source. There is no 4th address field. This is for case 2. What about case 3? In case 3, the 2DS bit is set to 1 and from DS bit is set to 0. In this case, the address 1 will be the receiving access point. You can see this here, receiving access point, and thus address 2 will contain the source address, address 3 will contain the destination address, and address 4 will contain the nothing. It is of 0 bytes. You can see that A is sending this frame to its access point. In this case, the access point will be the first address, the second address will be the source, the third address will be the destination to which this frame is supposed to be delivered, and there is no address for your address 4 field, that means 0 bytes. Now, for the last case in which both to DS bit is set to 1 and from DS bit is also set to 1. In that case, you can see here address 1 contains the receiving access point's address, which in this case is AP2, and the address 2 contains the sending AP's address, which in this case is AP1. AP stands for access point. And the address 3 consists of destination address, which is B, and address 4 consists of the source address, which is A. You might see there is some small gap here. What is this gap? This is nothing but the sequence control field, which we shall discuss in the next slide. So now you must have got an understanding why we have 4 fields, 4 address fields. So because by the combination of these 2 bits, they define which addresses are placed in which fields. Okay, so this is how the address fields are defined. These are the 4 cases, 4 combinations of the 2DS and from DS bits. The next comes is your sequence control field. So this field, often called as the SC field, defines a 16-bit value. It is of 2 bytes in length. Okay, so of these 16 bits, once again, the first 4 bits define the fragment. Usually you might ask me, sir, where do you get this fragment from? Once, if the packet is too large, or if you're receiving an MSDU which is huge size, you break it into smaller fragments. So if you're breaking them into fragments, that fragment number is given in this particular position, and each and every MSDU is given a sequence number. You know that each frame has a sequence number. That sequence number is copied into this field. So together you have 4 bits plus 12 bits, which is your 16 bits of your sequence control. So this sequence number is used to identify the duplicates. So if the receiver to identify if it is a duplicate or not, this sequence number is used. And if the frame is particularly broken into fragments, in order to order those fragments, you use the fragment number for the receiver to be able to identify the place of these fragments, which fragment is first, which fragment is second, for that particular manner. Okay, so this is the role played by your sequence control. The next field is your data field. So the data field contains the payload, which is up to 2312 bytes. The first bytes of this payload are in a format known as the LLC, or your logical link control. So this layer is the glue that identifies the higher layer protocol, so to which this payload should be passed. Those protocols are actually identified by your LLC layer. Now, the frame body, it is variable in length, because the minimum length is 0 bytes and the maximum length actually depends on the combination of MSDU length plus, if you are implementing WEP, then it is you have ICV plus IV. So what are these things? MSDU actually stands for MAC Service Data Unit, which is nothing but the payload passed on from the upper layers, the length of it, plus if you are implementing protected bit, or if I am implementing WEP, then ICV stands for integrity check value, plus IV actually stands for initialization value. So the minimum is 0 bytes and the maximum is the combination of these 3 things. But you can go up to 2312 bytes. So this is regarding your data field. And the next field is your FCS, which actually stands for frame check sequence, which is once again 4 bytes long. And for this 4 bytes, you get 4 into 8, a total of 32 bits. And we implement CRC32 mechanism to perform this, which is nothing but an error detection scheme, which adds a 32-bit FCS to every frame. Now, if you I told you there are 3 types of fields, right? So management frames have the same format as your data frames, plus a format for the data portion that varies with the subtype. So based on the subtype of the management frame, your frame body might contain different parameters. One of the most common management frames is the beacon frame, which is actually sent periodically from the access point, which contains a lot of information for the nodes within that particular BSS. So based on the type of the management frame, you might have different formats for your data portion. The control frames are short. Like all frames, they have the frame control, duration, and the frame check sequence fields. No, I also actually bought some sample formats of the different control frames that we use. This is the first one, which is your RTS, request to send frame, which contains your frame control field, then contains the duration field, which tells how long this particular transmission is going to take place, then followed by the receiver's address and the sender's address, followed by the FCS, which is nothing but the CRC32 or the 32 bits, which are used for error control. In case of CTS frame and an acknowledgement frame, you can see that there is no need for the sender's address. So the receiver's address is here, the receiver's address is here. That's why we call the control frames to be short frames. So this is these are all the different fields that are present within a MAC sublayers frame format defined for IEEE 802.11. Hope you understood this. And if you have any queries, do ping in the chat box. So once again, thank you for watching and do take care.